So I've made up a problem. We're going to use midpoints to estimate the integral from 1 to 3 of e to the 2x dx. And we're going to use 4 partitions. So setting this up in terms of midpoints, e to the 2x, that's probably a graph that we should know the general shape of. So it's kind of going to look like that. And I said that we're going from 1 to 3. So here's 1 and 3. So if n equals 4, then I know my delta x is going to look like 3 minus 1 over 4, or 1/2. So I've got all of my intervals now, but the fact that I said we're using midpoints means now we actually have to find the x value that's in the middle of each of these subintervals. So if the numbers are nice, sometimes you can just see what number goes in the middle. If the numbers are not nice, or if you can't just see what goes in the middle, then our formula for finding the number in the middle is to take the average of the two x values on the ends. And how do you find an average? You add them and divide by 2. So the midpoint here, the x value that we're going to plug in, is going to come from adding the two x values on either side of it and then dividing by 2. So 1 plus 3/2, that 1 I can think of as 2/2. So I'm looking at 5/2 divided by 2, and 5/2 divided by 2 would be 5/4. So I would take that 5/4 and plug it in to figure out the height of that first rectangle. So for my first rectangle, the base of that rectangle is 1/2, and the height is going to come from plugging in 5/4 to the function. Now we move on to the next rectangle. So I've got 3/2 and 2. So if I find that midpoint, I'm going to go ahead and rewrite that 2 as saying that 2 is secretly 4/2. So then I'm going to get my midpoint by adding them together. So I'll be at 7/2 and then divide that by 2. So 7/4. So my next rectangle, again, has a base of 1/2, but the height is going to come from plugging in 7/4 to the function. My next midpoint, if I'm halfway between 4/2 and 5/2, I add them up, so I get 9/2 and then divide by 2. So 9/4. And then our last rectangle, if I think about that 3 as really being 6/2, then I'll add these up, get 11/2, divide by 2, and I'll be at 11/4. And that would be my midpoint estimate with n equals 4. Now what the book talks about is that if I'm estimating, then the midpoint then our midpoint estimate is usually more accurate than our left endpoints or right endpoints, because we're sort of averaging out that we'd have a little bit of an overestimate and a little bit of an underestimate. For each of our rectangles. So again, the midpoint is not giving us the exact area, but it's getting us closer than the left endpoint or right endpoint. So what if we take the same problem, but we wanted to find the actual area using a Riemann sum? So if I wanted to write a Riemann sum for the true actual area, what the book tells us is that we can use left-hand endpoints, right-hand endpoints, or midpoints. My recommendation is to use right-hand endpoints, because if we always use right-hand endpoints, then our setup for what this Riemann sum looks like is the same each time. So if I use right-hand endpoints, then my Riemann sum is going to look like we're going to have the sum from I equals 1 to n. We'll have our delta x. So that's like the base of each rectangle, and then we need the height of each rectangle. And the height is going to come from f of x at our special point. Now, our book uses x star as the special point where we're finding the x value. So I'm going to erase all of my boxes over here so that I've got a little bit more space to figure out what that x star is. Okay, so back to our picture here from 3 to 1. So the first thing is that we need our delta x. And our delta x from the Riemann sum is coming from b minus a over n. And if it's truly a Riemann sum and our n is going to go to infinity, we're going to leave the n in there when we find the delta x. So here I'd be looking at 3 minus 1 over n or 2 over n. So that's my delta x value, and I can go ahead and put it into our summation already. So the next thing we need to figure out is what the x value is at our ith rectangle. So if I start drawing rectangles in here, here's one. And if we're going to use right-hand endpoints, then this x value that we're plugging in, we started at 1. And we've now moved over 2 over n. So I started at 1, and I've added 2 over n. For our second area, for our second rectangle, that x value that we're looking at, we've now moved another delta x. So we started at 1, but we've moved 1, 2 of the 2 over n's. And generically, when I get to my ith rectangle, that x star, or I like to just call it x, our x is going to equal our starting point plus I delta x. So for our particular problem, we started at 1, and when we get to the ith rectangle, we've moved I of our 2 over n increments. So what comes into our Riemann sum is our function, e to the 2x, evaluated at this x value. And then we quit and walk away.